Okay, section 1 of chapter 8 is new material. So it's adding and subtracting polynomials. Poly means many, all right? But we're going to need to know a couple of things. So to start off, a monomial mono means one. That means one term, okay? But the term can be either a number, it can be a variable, or it can be like a product. That means times of a number and however many variables, right? So a monomial, these are all examples of monomials. 4 is a monomial. 6x to the third, y to the second is a monomial because they're all multiplied, right? This is all multiplied. 5x is a monomial, okay? So it's one term. Now, polynomials are these monomials, but there's several of them, added or subtracted. Okay, so first thing we need to know how to do is how to find the degree of a monomial. So the degree, I have you writing that down, is the sum of the exponents of the variables of the monomial. Okay, so we want to look at the variables only, okay? So 5, I know there's a hidden exponent on that 5, but it's not a variable. So there's a hidden exponent on the x, which is a 1, right? And so the degree of this monomial is 1. It's a degree of 1. Ooh, I should zoom that in. Sorry, I see Araceli back there squinting like, what are you writing? Okay. Is that better? Excellent. All right. So the next one, this is a monomial as well. Again, the 6, we know it has a hidden one. It's not a variable, okay? The x has a exponent of 3 and the y of 2. So we add that together and we get a degree of 5. So the degree of this monomial is 5 because we add the 3 and the 2 together. Now this one, 4, don't get confused here. That doesn't have a variable, right? So the degree of this is 0. Makes sense? Okay. So raise your hand if you know the degree of 8xy below. Tell me what that degree is. Lydia, go. 2. Degree is 2. Because there's a 1 on the x and a 1 on the y. Raise your hand if you know the degree of b. Negative 7y to the 4th z. Speciosa, go ahead. That's right. Degree is 5. Don't forget there's a hidden variable on that z of 1. Okay, what's the degree of c? The number 11. Go ahead, Carla. 0. Okay, so that's how you find a degree. All right. Now, then the next thing is finding the sum or difference, adding or subtracting monomials only. All right. So if they have the same exact variable and exponent, or variables and exponent, you can add or subtract them. So this is 3x squared plus 5x squared. What that really means is you've got 3x squareds. Hold on, let's put this up here a little bit. You've got 3x squareds like this in one section, and then you're adding it to 5x squareds. Hold on. 3x squareds plus 5x squareds gives you how many x squareds? 8. The shortcut is to add the coefficient numbers, that's what those are called, that are before it. If they are the exact same variable with the exact same exponent, you can add them or subtract them. So like this one, see how this one, and this is kind of faded, but it says 4x to the third power y minus x to the third power y equals. This, they both have x to the third power and a y with nothing, well, a hidden 1. So you can subtract that. What is the hidden coefficient of this? Nope, 1. So what is 4x to the third power y minus 1x to the third power y? 3x to the third power y. Okay, you can add them and subtract them if they have the exact same variables and exponents on them. Okay, so far so good? Beautiful. Let's move on. So I copied this for you below. All right, a couple of details that I want to go over with you. All right, first of all, when we're writing these, we try to write them in something called standard form. Okay, standard form means that the degrees of the monomials in there, so each of these are a monomial, right? Inside here, 3x to the fourth is the first monomial. The second one is 5x squared. The third one is negative 7x. And the fourth monomial is 1. You write them from highest degree to lowest degree. Okay? So this right here, each one of these is a monomial. That's a monomial. Monomial, monomial, monomial. All together, this is called a polynomial. It's a bunch of monomials added or subtracted, okay? Now, the next thing is the degree of this polynomial. If I ask you not for the degree of the monomials individually, but the whole polynomial, it's the degree of the highest monomial. So the first one, the highest one, has a degree of 4. So the degree of this polynomial altogether is 4. You don't add them up, right? If they are separated by an add or a subtract, it's what's the degree of the highest monomial in the set. Last but not least, down here, I gave kind of like, I just copied this, the degrees, what they look like, and what they are called. So, like for example, this is a polynomial, is called a polynomial to begin with, right? That's the whole family of them. Now we're going to give them some names. Its degree is 0 because there's no variables. The name is, this is a constant because there's no variables on it. The number of terms, there's 1, and this is a monomial because there's 1, right? This one now, the degree of this is 1. This is linear. The number of terms, these are each called terms, term and a term. There's 2 terms, and this is now called a binomial because there are 2 terms. Okay, next one. This one has a degree of 2 because the highest one, exponent here, degree is 2. It's a quadratic function because the highest degree is 2. And there are 3 terms, and this is a trinomial. Okay, and as I stated to you before doing the video, we don't go above trinomial. We stop naming them. Everything above that is going to be a polynomial. All right, and so that's just the rest of them as we go down. All right, it goes monomial, binomial, trinomial, polynomial. Okay, but they're all considered polynomials if there's more than one term. All right, sorry, this got a little muddled here, so you should have it in front of you anyway. It's because my marker bled through this, all right? So I will rewrite this. It says, write these in standard form. This first one says 3x plus 4x squared. Standard form would mean that we have to start with the highest degree. So what's the only thing that needs to happen here to write it in standard form? Flip-flop. So in standard form, it would be 4x squared should come first, then 3x. This is the correct format for this. Okay, again, I will rewrite this second one because it got the marker bled through. The second one says 4x plus, oh no, I'm sorry, not plus 1. 4x minus 1 plus 5x to the third power plus 7x. Okay, not only do you have to have them in the order of degree, if there are like terms, you must combine them. Okay, so are there like terms? Yes, what is the like terms? 4x and 7x, right? So I really have, right, if I combine those, I have 11x minus 1 plus 5x to the third power, right? Is there any other like terms? No. Okay, but which one should go in front? What's our front runner here? The first one. They've already answered. Somebody who hasn't answered. Ivan, go. That's right. That's the highest. then what would be the next one in line? Keep going, Ivan.
11.
Plus 11x, and then minus 1. It goes by the order of the degree. This has a degree of 3. What degree is this one? 1. And what degree is this one?
0.
There you go. Okay, that's what we want to do. Perfect. Okay, the last part is adding and subtracting whole polynomials. All right, but you have to do it kind of like we did in elementary school, where you line them up and add them or subtract them. You don't necessarily have to line them up for addition, but for subtraction you do. All right, so like this one is combining two things: story problem, our favorite, and adding the polynomials. So it says, a researcher studied the number of overnight stays in a U.S. National Park Service campgrounds in the backcountry of the national park system over a 5-year period. The researcher modeled the results in thousands with the following polynomials. So here they are, two polynomials: campgrounds and backcountry. In each polynomial, x equals 0 corresponds to the first year in the 5-year period. What polynomial models the total number of overnight stays in both campgrounds and backcountry? So total means we got to do what with these? Add them. So you can, for addition, it's a little easier, right? You add like terms. So, and sometimes it helps to line them up. So I'm going to line them up like this: 7.1x squared minus 180x plus 5,800 plus, I'm going to do it like a big addition, okay? Plus, I'm going to line up 21x squared because I'm going to add those together. Those are like terms. Negative or minus 140x and plus 1900. So when you line them up, your like terms are lined up. So I'm going to add this. What's negative 7.1x squared plus 21x squared? You might need your calculator to make sure you are correct. Go ahead. 20, nope. Negative 7.1x squared plus 21x squared equals what? Joel, go ahead. 13.9, and then you put on x squared. Okay, be careful. Now when we're splitting this up, this is now negative 180x plus negative 140x equals what? Carla, go ahead. Negative 320x. And we write it back down just like this, right? And now we're going to add the last one, 5,800 plus 1,900. You want. Somebody do it. Stop trying to rely on other people. I will volunteer you. Ready? Let's go. Jaden, you got this one. 7,700, and it's positive, so we write it as a plus sign. So is there any like terms? No. This is the polynomial that they were asking for. This is the answer. What so it is a polynomial. What type of polynomial is it? Trinomial. So this one, its subterm is a trinomial, right? It's a polynomial because it fits in the family. Some of them are trinomials or binomials or monomials, right? Okay, last one then. Subtraction is a little bit more challenging, okay? Because the order matters, and sometimes we get minus negatives, okay? So in this one, what is the simpler form of, and I'll write this bigger, it says x to the third minus 3x squared plus 5x minus the quantity 7x to the third plus 5x squared minus 12. Okay, so I recommend for subtraction lining these up. Here's why. Watch this. So x to the third power, right? That's 1x to the third power. Okay, what goes underneath that one? What's its like term that's going to go under that one from the other one? What? So minus 7x to the third power. That goes under that, okay? Now the next one in line is minus 3x squared. Okay, minus 3x squared. What do I line up underneath that? Go, Matt. Yep, positive 5x squared. Okay. And then my next one is positive 5x. What do I line up underneath that? Carla. Nope. Is there an x on that 12?
No.
There's not. So there is not a number that we are going to be able to subtract from that, right? So for right now, let's leave that blank. All right. What about the minus 12? Which polynomial did it go with, top or bottom? Bottom, right? It went with the second one. So right here, this is like subtracting 0x. What do you think I'm going to put up here? 0. So with subtraction and addition, technically, right, especially subtraction, it matters that we fill in the zeros, because now watch. 1x to the third power minus 7x to the third power is negative 6x to the third power. Negative 3x to the second power minus 5x to the second power is negative 8x to the second power. And here's 5x minus 0x is still positive 5x. Here's where it matters. 0 minus negative 12 is positive 12. Is that a monomial, binomial, trinomial, or polynomial? Polynomial. That is it. It doesn't fit in any of the other ones. That's the answer. There's our first lesson of chapter 8. Boom.